All right, so today we're going to look at evaluating trig functions, and there are about four documents that you're going to need. You're going to need you're going to need these four documents: the all exam formula sheet, the reference angles formula sheet, reference angle chart, and this unit circle function values chart. And as you're going to see as we get started, there are more than one way to kind of answer the problems, and there's more than one way to, to evaluate a trig function. But before we begin, there was a question in the homework about section 9.2, problem number 4. So I'm going to bring that up.
Someone just left the course. Are we even allowed to do that?
Say that again.
I said someone just left the course. Are they even allowed to do that?
They left the course.
I mean they left the the thing we're in
session.
Right? Yes, sir.
That's you can go in and out. That's fine. This is going to be recorded, so if you have to leave the session, that's quite all right.
All right, I'm just sitting here and watching.
Okay, no problem. All right, so in this example, and I'm going to kind of leave this example simply because this thing has a square root. But we're asked to sketch out this point, and then we're asked to find all of the 6 trig functions for the angle, which this point, it actually lies on the terminal side. All right, so before we actually begin this particular problem, I'm going to pull up this all exam formula sheet. Okay, which is here. All right, and you're going to notice on this formula sheet, there aren't actually the 6 trig functions per se. Now, I don't actually require you to memorize all of the formulas for the course, okay, because you can use this formula sheet for anything we do in the course. However, there are some basic 6 trig functions that every trig student should understand. Okay, so here are those 6 trig functions. Now, as far as this slide is concerned, these 6 trig functions are actually listed out in a couple ways. They're listed out in terms of x, y, and r, right? So if you're plotting your point in a rectangular coordinate system, you would have, let's say for this example, right, we're given this point, and this point has an ordered pair coordinate x, comma, y, right? In order to graph this particular point, we would start at the origin, we would move x places to the right, and we would move up y places, all right? So this is actually ordered pair x, comma, y. We can also find the terminal side or the length of the terminal side by using the Pythagorean theorem. And then here are all of the 6 trig functions. The sine of some angle is y over r. The cosine is x over r. The tangent is y over x. And then we have the reciprocals. The reciprocal of sine is cosecant. So notice the cosecant is r over y, right? The cosecant is just the reciprocal, right? Reciprocal means when you flip-flop the numerator and the denominator. So the cosecant is a reciprocal of sine. Secant is r over x, and secant is a reciprocal of cosine. And we have cotangent. Notice that cotangent is x over y, and tangent is y over x, right? There's also one more piece that goes to this, which is I got too many windows up. The Pythagorean theorem, which is actually, I guess I'll go back to the document camera for this one. All right, so sorry about all the repetition, but repetition is a mother skill in this class. So the sine of some angle is y over r, cosine of some angle is x over r. Remember, the tangent is y over x. And then we have our reciprocals. The cosecant of some angle is r over y. The secant of some angle is r over x, and the cotangent is x over y. We also have that r is equal to the square root of x squared plus y squared, right, which is no more than the Pythagorean theorem. We also have x is equal to the square root of r squared minus y squared. Y is equal to the square root of r squared minus x squared. All right, so these are three additional formulas, okay, that follow with the 6 trig functions as they relate to x, y, and r. All right, so now we'll take a look at that problem. And we were given that the terminal side was, I'm actually going to sketch this out. So we were given -3 square root of 3. Let me just check and make sure that's right. Okay, a -3 for x. So remember, this is an x, and positive square root of 3 for y. So if we were to plot that point, it would actually lie in the second quadrant, right? Because as we plot the point, we will move -3 places to the left. So I'm not actually going to put out numbers on this scale. This is purely a rough sketch. I would go -3 units to the left. Since y is positive square root of 3, I'm actually going to go up. So I have my point, which is in the second quadrant. All right, so this is -3 comma square root of 3. This is my angle theta. All right. So now what we intend to do here is we're going to form an imaginary right triangle. So that means I'm going to drop a perpendicular. You always drop your perpendicular to the x-axis. So if I drop my perpendicular, that forms a 90-degree right angle. Right, so this would be x. This is y. And this is r. Now, one thing I didn't mention on the previous formulas is that your radius is always greater than 0. That simply means that r is always positive. All right, so no matter what x and y are, x can be negative, y can be negative, they both can be positive. R would always have to be positive. Okay. So now we're asked to find the 6 trig functions. We're asked to find the sine of theta, the cosine of theta, and the tangent of theta. And we're also asked to find the reciprocals. And it seems like I'm running out of space. All right, so the reciprocal of sine is cosecant. The reciprocal of cosine is secant. And the reciprocal of tangent is cotangent. Right. So remember that the sine was y over r. So if I go back to my sketch, x should be -3. So I'm just going to write -3 here. Y is the square root of 3. So I'm going to just simply write that here. What is r? Well, I'm going to find r by using Pythagorean theorem. And from those formulas, r was equal to the square root of x squared plus y squared. So notice that x is -3 and y is square root of 3. So I'm going to substitute x, which is -3. We want that squared, plus y, which is the square root of 3. We also want that squared. And that should be a 3. Okay. So now this is still under the square root. So -3 squared, a negative times a negative is a positive. 3 times 3 is 9. Plus the square root and the square are going to cancel. So the square root of 3 times the square root of 3 is going to give me 3. All right, 9 plus 3 is 12. Here again, all radicals must be simplified. So I have to simplify the square root of 12. So I'm going to write the square root of 12 as the square root of 4 times the square root of 3. The square root of 4 is 2. So positive 2 square root of 3 is my radius, or r. All right, so r is 2 square root of 3. So I'm going to put it all together in the 6 trig functions. So the sine is y over r. So y is the square root of 3. R is 2 square root of 3. And now I'm going to simplify. So the square root of 3 is canceled, so I have 1/2. In order to find the cosine, right, the cosine is x over r. I'm going to take x, which is -3, divide that by 2 square root of 3. All right. So remember, we still have to follow the rules from algebra. We must simplify all radicals, and we must rationalize all denominators. So in order to rationalize this denominator, and I'm actually going to do that on another sheet of paper because I'm running out of room. The cosine of theta is equal to x over r. That's -3 over 2 square root of 3. So in order to rationalize, I'm going to multiply the numerator and the denominator by the radical that's in the denominator. So I'm going to multiply by the square root of 3 over the square root of 3. So now I'm going to multiply. So in the numerator, I have -3 square root of 3. And in the denominator, when you multiply 2 square root of 3 times the square root of 3, well, 2 square root of 3 times 1 square root of 3, I can multiply 2 times 1, I get 2. I multiply the square root of 3 times the square root of 3, I get the square root of 9, which brings me back to 3. right? Because the square root and the square cancel. I now have negative 3 square root of 3 over 6. I can reduce 3 and 6. So this reduces down to negative square root of 3 over 2. So the cosine of theta is negative square root of 3 over 2. Now I believe if you put this in, it'll tell you that you have the right answer, but it's not in the correct form. That means you must rationalize the denominator. All right. So any questions about this cosine? All right, so now let's take a look at the tangent, and remember that the tangent is y over x. So y is square root of 3 over negative 3, which gives me negative square root of 3 over 3. All right, a positive divided by a negative is a negative. Since my radical is in the numerator, I don't have to rationalize. All right, so that's the square root of 3 over 3. Now for the reciprocals, the reciprocal of cosecant is the sine, and then vice versa. The reciprocal of sine is cosecant. So I can simply reciprocate 1/2. So if I reciprocate, I get 2 over 1. So the cosecant should be 2. The secant is the reciprocal for the cosine. So I have negative 2 divided by the square root of 3. So here again, I must rationalize. So I'm going to do that on a separate sheet of paper. So the secant of theta is negative 2 divided by the square root of 3. So I'm going to multiply the numerator and the denominator by the square root of 3. Right, so once I multiply, I get 2 square root of 3 over 3, but it's negative. So the secant is negative 2 square root of 3 over 3. And then lastly, for the cotangent, you should get negative square root of 3. Okay, so here again, you have to reciprocate 3 divided by the square root of 3. Well, negative 3, excuse me, divided, negative square root of 3 divided by 3. You have to reciprocate it as negative 3 divided by the square root of 3. And once you rationalize, your final result should be negative square root of 3. Right. Now, unfortunately for this radical simplification, you're only going to see this in this section of this chapter. All right, so any questions about, I believe this was problem number 4 from section 9.2. All right, so now we'll get into the next section, 9.3. I'm just going to close out that window. All right, so those are the 6 functions as they relate to X, Y, and R. We also have the 6 trig functions for angles that are not in a X and Y axes. All right, the sine is the opposite over the hypotenuse. The cosine is the adjacent over the hypotenuse. The tangent is the opposite over the adjacent. The cosecant is the hypotenuse over the opposite. Secant is the hypotenuse over the adjacent, and then cotangent is the adjacent over the opposite. Now, there's a saying we use, and you're going to hear me say this quite often, to memorize these sets of formulas. It's called Chief Sakatoa. So here's what that alludes to. So Chief Sakatoa. All right, so this is actually a mnemonic device, and mnemonic devices are used to make little sayings to help remember formulas. So the Chief Sakatoa, this kind of alludes to the sine is the opposite over the hypotenuse. The cop alludes to the cosine is the adjacent over the hypotenuse. And for TOA, it alludes to the tangent as the opposite over the adjacent. And of course, we have our reciprocals, but in the Chief Sakatoa, it gives you the main 3. There's also another one. Oscar had a heap of apples. So OH is for the sine, AH, the adjacent over the hypotenuse, is for the cosine, and then OA, the opposite over the adjacent, is the tangent. All right, so when you hear me say Chief Sakatoa or Oscar had a heap of apples, that's actually what I'm talking about. All right, so how do we use that to find trig functions? So here we're given a right triangle. Now you can only use the Chief Sakatoa for right triangles. That triangle must contain a right angle. If the triangle doesn't contain a right angle, then you have to use an alternative set of formulas, which we'll talk about in a later chapter. But here we're given a right triangle, and you're going to see something called standard labeling in these problems. So what standard labeling means is your capital letters are angle measures. Your lowercase letters are side lengths. So if this is angle A, the side opposite angle A is side A, and it would be denoted by a lowercase letter. This is angle B. The side that's opposite angle B is side B, and that would be a lowercase b. Here we have our right angle, and the side opposite the right angle is the hypotenuse, and the hypotenuse is always along the side of any right triangle. Okay, so we have this right angle, and we're asked to find the 6 trig function. All right, so before we find the 6 trig functions, the first thing I'm going to do is make a rough sketch of the problem, and we're going to label all of our sides. Okay, so the triangle looks something like this. This was angle A, so the side opposite angle A is side length A, and that was 7. This was angle B, so the side opposite angle B is side B, and that was 24. Here we had C, the side opposite C is side length C. Since angle C is a right angle, then C is actually the hypotenuse. So the first thing I like to label in my triangles are the hypotenuse. Okay. So we're asked to find the sine of A, the cosine of A, and the tangent of A. Okay. So now the first thing we need what's called a reference angle. And since we're finding the sine of A, cosine of A, and the tangent of A, I'm going to use A as my reference angle. Okay. Now, reference angle, by definition, is any acute angle. Right? Acute angle is an angle that's less than 90 degrees. All right, so I've labeled my hypotenuse. Since A is my reference angle, the side opposite angle A is my side opposite. This is my hypotenuse. Therefore, side B is the adjacent side. Right. So I have everything I need for my chief SOHCAHTOA. The sine is the opposite over the hypotenuse. The opposite is 7. The hypotenuse is 25. So my sine value is 7 over 25. The cosine is the adjacent over the hypotenuse. My adjacent is 24. My hypotenuse is 25. The tangent is the opposite over the adjacent. My opposite is 7. My adjacent is 24. And now I can find the reciprocals. The reciprocal of sine is cosecant. So I can just reciprocate that. That's 25 over 7. The reciprocal for cosine is secant. So I can reciprocate it. That's 25 over 24. The reciprocal for tangent is cotangent, and that's 24 over 7. Okay, I'm going to go back to the notes. Okay, right here. All right, so we found the 6 trig functions for this angle. Excuse me, for this triangle. Okay, now we're given what are called cofunction identities. And in any right triangle with a right angle C, and for whatever reason, C is normally your right angle. The other angles are your acute angles, and they're complementary, which means that if you were to add these two angles together, you would get 90 degrees. The sum of the interior angles of any triangle should be 180 degrees. Right, so you should be able to add up all 3 angles, and they should give you 180 degrees. All right, here's some formulas. The sine of A is actually equal to the cosine of B. The tangent of A is equal to the cotangent of B. The secant of A is equal to the cosecant of B. These are what are called cofunctions. Here are a set of cofunction identities. Notice that these identities are twofold. One set of formula deals with angle measures that are in degrees. The other deals with angle measures that are in radian mode. All right, so these are the same formulas, but you must be mindful of your angle measure, if it's degree or if it's radian. So this first formula says that the sine of A is equal to the cosine of 90 degrees minus A. The cosine of A is the sine of 90 degrees minus angle A. And then the tangent of A is equal to the cotangent of 90 degrees minus A. Right? I just mentioned the main three, but notice there are six. The second set of formulas, they're using their exact same formulas, but instead of using degrees, they're using radians. So recall from the unit circle that 90 degrees is equal to pi over 2 radians. So notice for this formula, if your angle is in radians, the sine of A is equal to the cosine of pi over 2 radians minus A. The cosine of A is equal to the sine of pi over 2 minus A, and the tangent of A is equal to the cotangent of pi over 2 minus A. Okay, here's an example that uses these formulas. I believe there is one somewhere in the homework. Okay, just to show an example, because there isn't a physical example on the slides. Okay, here's on problem number 9. It says rewrite cosine of 75 degrees in terms of this cofunction. The first thing you must do is refer to the formulas. Now, for whatever reason, the cofunction formulas are not on that all exam formula sheet. Let me just make sure, but I don't think that they're on the all exam formula sheet. However, they are in these lecture notes. Okay. All right, so our problem, I'm going to make this slightly smaller. It says rewrite the cosine of 75 degrees in terms of this cofunction. So I'm going to simply find that cofunction. It says the cosine of A is equal to the sine of 90 degrees minus A. So if I use that formula, I'm simply going to treat A as 75 degrees. So just to write this out so that everyone can see. Oops. Okay, find the cofunction for the cosine of 75 degrees. And if you refer to the formula sheet, the formula was the cosine of A is equal to the sine of 90 degrees minus A. So I'm simply going to substitute A for 75. So the cosine of 75 degrees is equal to the sine of 90 degrees minus 75. So 90 minus 75 should give us 15. So the cosine of 75 degrees should equal to the sine of 15 degrees. So I'll go back. All right, so we got the sine of 15 degrees. All right. Okay, I'm going to scroll down slightly, and these two things are sort of related. This reference angle and this function of values for special angles. Now, this little chart, it gives you the 6 trig functions for the 30 degree, 45 degree, and 60 degree angle, which are actually called reference angles. A reference angle, by definition, is any angle, any acute angle. All right. So in this problem, we're asked to find reference angles for a 218 degree angle and a 5 pi over 6 angle. In order to find the reference angle, we're going to need this chart as well as this chart. Okay. So the first thing I want to do is just kind of explain what's going on with this reference angles chart. The first thing is that notice you have the x and the y axes. Those x and y axes split this plane up into 4 regions, right? Quadrant 1, quadrant 2, quadrant 3, quadrant 4. And notice this ASTC. And from the last lecture, the ASTC alludes to the mnemonic device all students take courses, which means that in the first quadrant, all 6 trig functions are positive. In the second quadrant, only the sine and the cosecant are positive. Everything else is negative. Right? All other 6 trig, all the 4 trig functions are negative. In the third quadrant, only the tangent and the cotangent are positive. The other 4 remaining trig functions are negative. And in the fourth quadrant, the cosine and its reciprocal, the secant, are positive. The other 4 values are negative. Okay, that's the ASTC. It gives you the signs for the trig functions in the quadrant. Next, we'll look at the reference angle. If your angle is in the first quadrant, it is a reference angle, theta, right? Whatever you're given. If your angle is in the second quadrant, you find the reference angle by using these calculations. It's either 180 degrees minus theta, and here again, theta is the angle measure you're given. Or if your angle is in radian measure, is pi minus theta. In the third quadrant, the reference angle is theta minus 180 or theta minus pi. And if your angle is in the fourth quadrant, you would find its reference angle by the following: 360 degrees minus theta or 2 pi minus theta. All right, we're going to use this to find the reference angle. Okay. All right, so I'm going to go back to the camera. So we're asked to find a reference angle for 218 degrees. So the first thing I'm going to do is I'm going to actually sketch out a 218 degree angle. Well, this is 0, 90 degrees, 180 degrees, 270, back to 360. So a 218 degree angle would lie in the third quadrant. Right, remember that all of our angles are in standard positions, so they start along the positive x-axis. Since I want 218 degrees, that angle should be somewhere in the third quadrant. Right, so now how do I find the reference angle? Well, from this point, I'm going to look at the chart. So remember the chart for the reference angle. If it's in the first quadrant, the reference angle was theta. If it's in the second quadrant, the reference angle is 180 minus theta. If you're in the third quadrant, the reference angle is theta minus 180 degrees. Right. So in order to find the reference angle, I'm going to take theta, which is my, okay, so this is my 218 degree angle. It's in the third quadrant. So the reference angle formula is theta minus 180. So theta would be my given angle measure of 218 minus 180. And once I subtract the two, I should get 38 degrees. All right, so 38 degrees is an acute angle, and it's also a reference angle for a 218 degree angle. Okay, we'll see how this reference angle relates to the given angle in just a second. Okay, but here we're just finding out what these angles are. And this should be find a reference angle for. All right. Now we're asked to find a reference angle for a 5 pi over 6 degree angle. All right, so I'm going to do the same thing. Okay. All right, so first of all, where would we find a 5 pi over 6 angle? Well, as far as the sketch is concerned, I'm going to convert 5 pi over 6 to a degree measure. So from the unit circle, we know that pi is equal to 180 degrees. So if I multiply 5 times 180, I get 900. And if I divide that by 6, I should get 150 degrees. Right? So you may want to just verify that with your calculator. You can take pi, convert it to 180, right? So if you multiply 5 times 180 divided by 6, you should get 150 degrees. All right, so if I list everything out, 150 degree angle would lie in the second quadrant. Right, so remember that all of our angles are in standard position. A 150 degree angle, and I'm going to call this angle theta. It should lie in the second quadrant. Okay. So now just one thing about this, if you're given a radian measure to begin with, it's going to want a radian measure answer. All right, so I simply just converted this to a degree measure just so in my head I can get straight on which quadrant it's in. But I know that this is 5 power 6 radians. So from those formulas, if your angle is in the second quadrant, then that reference angle formula was 180 degrees. Well, in this case, since I'm using radian measure, I'm going to use pi minus theta. So for the reference angle, I'm going to use pi minus theta, which is 5 pi over 6. I'm going to write it as a fraction. So now what I'm going to do here is I'm going to treat pi as a fraction. Right? In order to subtract fractions, you got to have a least common denominator. The least common denominator between 1 and 6 is 6. So now I just want to write these as equivalent fractions. So for this first fraction, the 1 was multiplied by 6 to give me the least common denominator. So I must multiply the top by 6. This second fraction is going to remain the same. Since I have a common denominator, I'm going to keep the common denominator. And if I combine my numerator, 6 pi minus 5 pi is pi. So my reference angle for 5 pi over 6 is pi over 6. All right, so if I look at these as far as degree measures are concerned, 5 pi over 6 is 150 degrees. And pi over 6 radians is 30 degrees. Right? 30 plus 150 is 180. Pi over 6 plus 5 pi over 6 is pi over 6. Okay. All right, so any questions about a reference angle? Okay, now here's the last thing we're going to do for today. We're going to tie all of this stuff together. We're going to tie in the reference angle chart. I'm going to go back to our shared screen for a second. All right, so we're going to tie these things in together. We're going to tie in this reference angle chart, and we're going to tie in this function of special values. And we use these things in relation to find the values for trig functions. Okay, so this is the one I want. Okay, so here I'm asked to find all 6 trig functions for 210 degrees. Right, and we're going to look at this in a couple of ways. All right, the very first thing we can do, I'm going to go back to the document camera for just 1 second. So we're concentrating on 210 degrees. So we want to find the 6 trig function values for the sine of 210 degrees, the cosine of 210 degrees, the tangent of 210 degrees, and then we want the reciprocals, the cosecant, the secant, and the cotangent. So the first method we're going to use this reference angle method. All right, so remember that a reference angle is no more than an acute angle. The first thing you want to do is determine the sines. Right. So what do I mean by determining the sines? Well, if we were to sketch out a 210-degree angle, and where should I put that? I'm going to put that here. This is 0, 90, 180, 270, 360. All of our angles are in standard position, so they start along the positive x-axis. So a 210-degree angle would lie in the third quadrant. Right. So our angle is in the third quadrant. If you take a look at the reference angle chart, I'm going to bring that up. All students take courses. These are what give you the sines for your trig function. So if you're in the third quadrant, only the tangent and the cotangent are positive. All of the other trig functions are negative. Okay, so I'm going to label that out. Right, so in the third quadrant, only the tangent and the cotangent are positive. Everything else is negative. So that's the first thing I did, was determine my sine. The second thing you want to do is find the reference angle. Well, based upon what we just found, we know that 210 degrees is in the third quadrant. If you're in the third quadrant, the reference angle formula is the given angle measure minus 180. Right. So you can verify that if you take a look at the reference angle chart where we had all students take courses. Notice in that third quadrant, the reference angle formula was theta minus 180. So we would have a reference angle of 30 degrees. So how does this help us? The third thing we want to do is use the function of special values chart, okay, which is this. Okay. So what we'll do is we will use 30 degrees as a reference angle. So this means that the sine of 30 degrees and the sine of 210 degrees are exactly the same. The only difference is the sine. So the sine of 30 degrees is 1/2. The sine for 210 degrees is negative 1/2. The cosine of 30 degrees is square root of 3 over 2. The cosine of 210 degrees is negative square root of 3 over 2. The tangent would remain the same, square root of 3 over 3. The cosecant is negative 2, right, for 210 degrees. The cotangent of 30 degrees is square root of 3, which is also the cotangent for 210 degrees. I think I missed one. Secant of 30 degrees is 2 square root of 3 over 3. The secant of 210 degrees is negative square root of 3 over 3. So I simply transfer these values to the values for the 210 degrees. The difference is the sine. Okay. Right, so I don't know if I can fit all of this on one screen or not, but notice I simply took the values for that reference angle as the values for this angle. The difference is the sine. Okay. So that's the first method. It's a little, well, I won't say it's complicated, but there are a few steps involved. And here are the 3 steps. The first thing you do is determine the sine. The second thing you want to do is find a reference angle by using that reference angle chart. The third thing you do is use the function of special values, right? And you just transfer those values to your given angle. Here is a second method to find these 6 trig functions. All right, you can use and this is from that formula sheet section. This is the unit circle function values. I mean, they're laid out here. If I look at 210 degrees, and we can compare these with the reference angle calculation. This cosine for 210 degrees is negative square root of 3 over 2, which is what we have. The sine of 210 degrees is negative 1/2. The tangent is square root of 3 over 3. The secant for 210 degrees is negative 2 square root of 3 over 3. The cosecant for 210 degrees is negative 2. And the cotangent for 210 degrees is the square root of 3. All right, so this is a straightforward method to find the 6 or to find the trig or the function value for any or the value for any trig function, right? Any one of the common trig functions, I should say. Now here's the third method. The third method is the unit circle. So I'm going to pull up that all exam formula sheet, and on the last slide, or the last, excuse me, it's the next to the last page, there is the unit circle. Okay, now one thing about the unit circle, notice that all of the angles are positive in this unit circle. I'm looking for 210 degrees, notice that it's in the third quadrant. However, on this unit circle, I'm only given X and Y. I'm only given the cosine, right? So if I'm using the unit circle, the cosine is X over R. Okay, and I really want you to see how this relates. I'm going to go back to the document screen for 1 second. Okay, I'm just sort of going back through my notes. So notice these were the 6 trig functions as they relate to X, Y, and R. Notice that in the unit circle, R, which is the radius, that's equal to 1, right? Because the formula for the unit circle is X squared plus Y squared equal 1. That's the formula for a circle with a radius of 1, right? So if R is 1, the sine value for any angle in a unit circle becomes simply the Y value. Here again, if R is 1, the cosine for any angle in the unit circle is the X coordinate. Now, in order to find tangent, we would still have to put Y over X, right? But the stipulation here is that the radius is 1, or R is equal to 1. Right, so for 210 degrees, we can actually verify the cosine is negative square root of 3 over 2. The sine, which is the Y value, is negative 1/2. Now, how would you find the tangent value using this unit circle? Well, I would take my Y value, right, and I would divide it by X, and I would simplify, right, because from our formulas, the tangent is Y over X. So I would take negative 1/2, I would divide that by negative square root of 3 over 2. And you should get Cal actually worked that one out. Now keep in mind, this is just the third method I'm using to find the function values. All right, but just to show how this works, okay, here it is right here. So notice that the cosine was square root of 3/2. The sine was -1/2. So if I wanted to find the tangent of 210 degrees, that's equal to y/x. I would simply take the y value, which is -1/2. I would divide that by x, which is -√3/2. And there's this formula for algebra, and it says that a/b divided by c/d, that equals to a times d divided by b times c. So I can take the very top and the very bottom, and I can multiply those. And I can divide that by the product of the bottom of the top and the top of the bottom. All right, so using that over here, all right, a negative divided by a negative is a positive. I can take the very top, which is 1. I can take the very bottom, which is 2, and multiply those, and I get 2. I can multiply the bottom of the top and the top of the bottom to get 2√3. And then once I rationalize, I should have 2√3/6, which would give me √3/3. So I would really not want you to do it this way, simply because of the rationalizing and the simplification. The next method would probably be to use a reference angle method if you were asked to find a reference angle. The easiest method is to use that chart, but I want you to see the differences in all three, because certain questions ask for certain elements. So I guess with that, we'll kind of end class today. Well, I'm going to stop the recording.